There was a time in America where abundant electrical power was not available. This Kohler Model KH motor generator set supplied power for American rural residents from the year 1928 to about 1948. These were very plentiful. Not only were they used for providing electrical power for farmers, rural residents, businesses, they were also used in large numbers as generators for airway beacons during the early years of airmail. Generators such as this one would provide 2,000 watts, 110 volts DC to illuminate the million candle power beacons that were used for nighttime navigation. This is a Kohler Model KH. Serial number is 88541. I'm not actually sure when it was built. It could have been built anywhere between 1926 and 1948. I obtained this unit a couple of years ago in Gilroy, California. I brought it here to Redwood City, where I've refurbished it. It didn't need a lot of work. It did not have the regulator, and I did made a handmade regulator. I can talk about that a little bit later, but let me just go over some of the features of this generator. One of the things about these Kohler generators that's a little unique is the split system. You can see the radiator fan assembly is mounted between the motor and the generator, and that was in order to make a compact unit. Also, you notice on this one it has a crank. Many of these were built with electric start, and this one can be made to start with external batteries, and the crank can actually be removed. Some of the features on this one you can see is the carburetor. I'll point that out. The carburetor is up on the top of the engine. It's got a float bowl. You can see this little unit right here is the solenoid actuated choke. There's actually a manual choke here, but the solenoid actuated choke, along with allowed for the remote electric start capability with the DC batteries. Visible on the other side, you can see that's an AC Alice Chalmers fuel pump. Let me see if I can show the other side of this unit. I'll get over here. You see the 4 spark plugs. My shadow in there? That's too bad. Let's see. There's a 4 spark plugs. There's the AC fuel pump, fuel sediment bowl. See the oil filter, and there's a little. Yeah, my shadow's in the way. There's a little Kohler. Not Kohler. That's a Wisconsin fuel tank, and I built that to supply fuel. It's got and in the back is hand-built regulator assembly that I made, and underneath that is that big pod is the actual generator. This unit is a DC generator. They were built both in AC and DC. So let's see. Go over here, we can see a magneto assembly. This is, you can see the magneto, that's a Wico magneto. Just in front of that is a regulator, the gauge for the oil pressure. Tell you about the engine. It's a 4-cylinder overhead valve engine. The bore is 2 inches, the stroke is 3. If you do a little calculation, you'll get to about 36 cubic inch displacement. Produces 12 horsepower, has 5-to-1 compression ratio, and I'm going to try to start it here, and you can see that it turns over quite easily because of that low compression. I can show you what the generator assembly actually looks like here. I don't knock this over. Let's see if I can see what's going on here. So let me take this off, and this looks like it's about ready to come off. Oh yeah. So that is the actual generator, part of the generator. And zoom in here a little bit. What am I looking at? There it is. So there are 4 poles, 2 pole pairs, and 2 sets of commutator brushes. So in a sense, it's it's 2 generators in parallel, mounted on the same armature shaft, and that produces very consistent DC power. I'm going to start it in a minute, or I'm going to try to start it. And one of the things you might notice when I start it is the these lights down here, which I'm going to try to make those visible. They will not illuminate immediately, and that's because, like all generators, it has to have an excitation field or excitation current for the field in order to produce the magnetism which the armature uses to produce the actual current. So a generator like this has sort of a startup mode where it's just using the residual magnetism in the pole pieces to provide the field that's initially used for the armature to provide the current, which is fed back to the field. This unit has a compound wound field. There's a series field winding, which is, in other words, the field winding is in series with the load, and it has a parallel winding, which is in parallel with the load. The series winding provides a bit of load regulation. In fact, all the load regulation. So the heavier the load, the more field current, since all the load current goes through the field, and that provides a stronger field for the armature. It also has a parallel winding, which provides a consistent field magnetism regardless of the load. There's actually a third winding, field winding, which is used to start the generator if you have external 24-volt DC batteries. And that winding, together with the armature, is used to actually charge the batteries as well. This is my, let me get a picture of my regulator. This is my regulator assembly. I have a potentiometer on the parallel wound field, or the shunt wound field, I guess is what's really called, so that I can adjust the voltage, output voltage, by adjusting the field current. There's the circular meter there is the output voltage, and the rectangular meter is the output current, and then the pot right below that, the knob, controls the field current. So let's see if I can start this. It hasn't been started several months now, and I'm going to back off so that maybe I can get the lights in here too, or I can reposition the lights. Let's get the little camera angle just right here. The sun's pretty bright this morning, so I'm going to move the lights so you can see those. Hopefully I can get it started. Hasn't been started in a while. Get a little fuel prime and wiggle the choke. And here we go. Let's try this. Oh, there's a kill switch. Gotta make sure that's in the right position here. Run. There we go. Need a little work here. Let's try it again.